Hello and welcome back to another exciting episode of Mr. Richards, that's me by the way, Teaches Science. That's right, Mr. Richards Teaches Science. So today we have a very exciting episode all planned out for you. And let's just jump right in and see what it's all about, because today you get to learn about studying ecology. That's right, all about studying ecology. Alright, so let's see here. What do we got to do today? Alright, well, man, I'm in the wrong place. Let's get me over here like this. There we go. Okay, so the first thing, alright, is the levels of ecological organization. Alright, so let's talk about what ecology is. So ecology is the study of how organisms interact with each other and their environments. Okay, so every single one of you are organisms. That's right. And ecology is the study of you and how you interact with each other and your environment or this classroom, okay, or the classroom that you're sitting in. And so scientists, to better study ecology, they study it at different levels. So there's the individual, such as an organism like a frog, and then they can study whole populations, so members of the same species, so a whole bunch of frogs, or the organisms living in a community, which would be all the populations in an area, so like the frogs and the fish, and what else could we say? Oh, insects, stuff like that. All right. Then there's ecosystems, so that would be all the living and non-living things living in an area, or the whole biosphere. So all the parts of Earth that host life. So when we talk about the biosphere, that's the entire planet and all the parts of the planet that host life. So my question for you, based on this information that we've put together right here, all right, how do we, as human beings, study life? And so I'm going to sit here and I'm going to wait. I'm going to let you guys talk. All right, remember how we do this. All right, I know it's been a while. So what you want to do is you want to take 1 minute and you want to talk to a shoulder partner and about the question, why do we study life? And so I'm going to start my timer here on my phone. All right, so messaging, go right here to time. Hey, be quiet. Stop talking. It's not time to talk yet. Shh. Okay, set my timer for 1 minute. All right, and it's going. All right, you guys see that? So you got 1 minute. Talk. Go. Hurry up. 1 minute about why do we study life? I'm sorry, not why, but how. How do we study life? Whew, that scared me. How do you turn this thing off? I figured it out. Technology, you gotta love it. All right, so I'm sure you guys had really good conversations with you and a shoulder partner. So what I want you to do now is you and your shoulder partner, I want you to team up, all right, with another group of shoulder partners. So now we're gonna have 4 people talking, all right, and I want you guys to discuss how do we as human beings study life, all right? And so I'm going to give you guys 2 minutes to do this. 2 minutes, all right? So I'm going to start my phone right here. 2 minutes, go. Timer's going. 2 minutes. 2 minutes. 2 minutes to talk about it. Talk about how it. Hey, you're supposed to be talking about how do we study life, not about whatever it was you was talking about. You know who I'm talking to. Mm-hmm. What you looking at? Okay, let's call time. You guys aren't really talking about what you're supposed to be talking about, but that's okay. All right. Now, how do I stop this timer again? Oh my gosh. Cancel. There we go. All right. So, yeah, how do we study life? So the important thing that, how you can answer this question is based upon what you want to know. All right. So, here, let's do this. So the way it works is let's say you're wanting to study a plant. And all you want to know is like how the plant is structured. Then you want to study the organism. All right. And if you wanted to study how the plant reproduces, then you'd want to study a couple of plants. If you wanted to study how the plant interacts with other organisms in the environment, then you'd want to study the community. Or if you wanted to study how all the organisms or how the plant interacts with the soil, then you'd want to study the ecosystem. And then finally, if you wanted to see what role the plant plays in the entire world, then you'd want to study the plant as far as the whole ecosystem. Does that kind of make sense to you guys? Awesome. Okay. So just real quick here. On the next slide, it shows here just the visual representation of the levels of ecological organization. So if I put 2 slides toward, you guys think it's important? That's right. And plus, it was a bell work question, too. You're absolutely correct. So that's 3 different times that I've mentioned this. So yes, you're going to see this again on the test. Absolutely. You're going to see this again on the test. All right. So individual frog, population of frogs, frogs with plants and worms and insects and fish and all that kind of stuff. How many of you had frog legs? Frog legs are good. Yes, they're wonderful. I remember hunting bullfrogs whenever I was a kid. Go out to the pond late at night, spotlight in your head, 22, pop. There, got a good one. Yeah, then you go back. Yeah, fry them up. Oh, yeah, perfect, yes. And yeah, they do taste kind of like chicken. Yes, they do. Okay, anyway, the community, and then you got the ecosystem right here, so that'd be like the whole area, and then the whole biosphere is the whole Earth. And so it's important to study things at different levels based upon what information you want to know. All right, moving right along here. So habitat. A habitat is where the species lives. Okay. Your bell work question is what's the definition of a habitat? So hopefully you guys all know that. And when we're talking about habitat, there are what we call biotic factors and abiotic factors. So bio means, what does the prefix bio means? Life, that's right. So life factors are things that are or used to be living. All right, so organic material. Abiotic, A before something means not. So abiotic means not living, and it's things that have never been alive. All right, so those would be like rocks, minerals, stuff like that. All right, and so a species habitat, there's a typo there, includes both biotic and abiotic factors. Okay, and then the habitat provides the organism with all the resources it needs for survival. So an organism needs both biotic and abiotic things or resources to survive. Even we as organisms, we need that. All right, so some information about habitat. Moving right along, we got to talk about populations. All right, and so when we talk about populations, there's some key things that we have to talk about. First, there's the population size. So that would be the number of organisms in an area. And so if you think about it, when you enter Anderson, there's a sign that says population so-and-so. When you enter Neosho, there's a sign, population so-and-so. Joplin, there's a sign that says population so-and-so. That's how many people or organisms live in that area. And so when we describe a population, we want to talk about how big it is, because that's important. Okay, then we talk about population density. Population density is the number of individual organisms in a certain area. Okay, and the reason why we need population density is because if we're going to count all the people in the United States, okay, we want to know how well they're distributed throughout that area. So some places have a lot of people living there that's very densely populated, like New York City, okay, where there's millions of people that live in a couple of square miles. Or we can look at McDonald County, okay, where there's a few thousand people that live in several hundred square miles. And so population density is extremely important. Okay, the age structure. And what the age structure does is shows the different ages present in a population. All right, and so that's important because if there's nothing but a whole bunch of older organisms living in a population, then it's not going to be as successful as if there's just a whole bunch of young ones or in between. So if you think about age distribution in the United States, where would most of the older population tend to go to? Florida. That's absolutely correct. Florida. Mostly because it's a great place to go. If you've never been there, try going. It's wonderful. It's beautiful almost all year round, except for the hurricanes and the sinkholes. And all the people. But the beaches are nice. All right. So anyway, and then everybody else is spread all throughout the country age-wise. But anyway, I was just picking on Florida. So anyway, the sex ratio, proportion of males to females, normally that's evenly distributed. So 50-50 or really, really close to that. Would there be a problem if there's more females or less females or more males than females? Absolutely. For reproduction purposes, absolutely, there'd be an issue there. Okay, so talking point. I'm not going to do the whole thing where we stick to the video, stuff like that, and we're just going to pause it this time. All right, so the question is why is it important to describe populations? Why do you think it's important for us to do that? And so what I want you to do is for 1 minute, hopefully somebody's got a timer or something like that, or just as close as you can get. For 1 minute, talk with a shoulder partner, all right? And then for 2 minutes, those two shoulder partner groups team up, discuss it, and then come back and restart the video. So, and I'll just be hanging out here in cyberspace waiting for you guys to finish your discussion. Okay, so go ahead and click the pause button on the video. Wait, not yet. I didn't say now. Wait until I say now. Very important, okay? I may have some last piece of advice that I need to give people, and if you pause the video too soon, then they'll miss out on that. But go ahead and pause it now. No, it's okay. Pause it. Awesome. Okay, good job. Thank you. Okay, so I'm glad that you guys are back. Hopefully you had some really good discussion. And so my answer to this, now there's tons of reasons why we'd want to describe population. To me, the key thing is it helps us learn more about an organism. That's the key, is it helps us learn more about an organism. And so to me, it's just showing one more piece of the puzzle as far as how well a population is doing. For example, if there's not very many organisms in the population size and that number continues to decrease, the population's not doing very well. However, if the population size is increasing, then it's doing well. If the population density it's really dense, then that means that more organisms are competing for resources. And so that could lead to a bad thing. Like I said earlier, age structure, if a lot of them are really, really old and there's not really any new ones, then that shows there's a problem with reproduction. And if there's no really old ones and they're all young ones, then that means something is causing them to die off. So maybe there's a predator that's eating them or something like that. And then sex ratio, of course, if there's a whole bunch of males being born and no females, then how is the species going to reproduce? So the reason why these things are important is because it gives us information about how well a population or how well a species is doing. Okay, we're almost done here. Just got a few more slides left. So let's see what's next. All right, population growth. Okay, so factors that determine population growth. So there's birth and death rates. So whenever you're talking about a population and you're going to figure its growth, you have to add births and subtract deaths. Makes sense, right? So if you have 100 people, all right, and 5 babies are born and 5 people die, then what's your growth? 0. Absolutely right. That's 0. Okay, and then you have immigration. So that means people come in. You have emigration, which is the departure of individuals, so people leaving. And then you have migration, which is the seasonal movement of individuals. All right, so migration is where people move around based upon usually crops, or for birds. That's right. They fly south for the winter and then fly back north because it's warm. All right, and so those type of things affect population growth. All right, so look at this. It's a talking point already. I must want you guys to talk a lot. Maybe it's important or something. Okay, so here's the talking point. Once again, I'm not going to put the phone up there. Do the same thing as last time. 1 minute with a partner, 2 minutes with 4 people. Talking point is, why are there more bacteria than whales? May seem like that's an easy question, but see if you can come up with it. Why are there more bacteria than there are whales? Okay? Pause the video now. Okay, welcome back. Boy, for me, that was instantaneous for some weird reason. It was like I was frozen in time, and then bam, I was back. Wow, that's cool. Anyway, all right, so here it is. It's really, really simple, okay? So lots of reasons why, but the big reason why is that the lifespan of a bacteria is much shorter than that of a whale, and when bacteria reproduce, they reproduce a lot quicker than whales do. So if you have one bacteria, okay, and it reproduces, it has 2, and those 2 turn into 4, 4 turns into 8, 8 turns into 16, 16, 32, so on and so forth. Okay, and that happens in a few hours. Whales, you have to get 2 whales together to make 1, and then that takes a year versus hours. So in the year it took the 2 whales to make 1, there can be billions of bacteria made. And so all it has to do with is how fast an organism reproduces and how many resources it takes to do it. So what's going to take more resources, the whale or the bacteria? Okay, so the size of the organism determines how fast it can grow. So the smaller an organism, the more likely there is to be more of them. Absolutely correct. All right, some good points. I hope you guys had some really good discussions. I wish I was here to hear them. Okay, so how do populations grow? So there are 2 basic types of growth. There's what's called exponential growth, which means the population increases by a fixed amount. So let's say the population increases by 10% every year. Okay, so that's a set amount. So start with 100, 10%. Next year that's 100 plus 10, so that's 110. And then next year it grows by 11, so that's 121. And then it grows by 12, and that's 133. And so you guys can see how exponential, it just keeps growing and growing and growing. Logistical growth, on the other hand, describes how a population's growth is slowed and stopped by limiting factors. Okay, and so an example of this would be the sheep-wolf predation. All right, and so what happens is the sheep start multiplying a lot, and the wolves start eating them, and then the wolves start getting a whole bunch of them, and then there's more wolves, and the wolves eat all the sheep, and then there's no sheep. And so then the sheep stop, and then the wolves die because there's no sheep to eat, and then all that's left is grass. Or maybe the sheep take over and kill the wolves. Who knows? Or maybe the wolves or the sheep will take over the earth. Don't know, but that's the way it works sometimes, maybe, in some real world. Tell you what, there's a program that does that I can show you. And what I'm going to do is, actually, I'm going to pause the video and I'm going to show it to you right now. So I'm going to pause this and I'll be right back. Okay, so this right here is a program called NetLogo. I just happen to have it installed. It's actually a programming language, but in this programming language is a thing called wolf-sheep predation. All right, and so we'll get this thing loaded up here. All right, and get some screen situated here so you guys can see. All right, and so we'll hit setup. Okay, and then what we got is we got grass. And we got sheeps are the white things, wolves are the black things. And we got some variables that we can set over here. And I'm going to hit go. And then we can watch. And as we see, the population of sheep goes way up. And then as the population of the wolves go up, then the population of sheep go down. And then you can kind of see what's happening here. They kind of go back and forth, until eventually the wolves ate all the sheep. And now the wolves are dying. And now there's no wolves. And now there's nothing but grass. Everything's dead except for the grass. So no consumers whatsoever. All right. So what we can do here is we can turn the grass on to make the grass grow. And so we're going to do a limiting factor. All right. So let's look back over here. All right. So stop by limiting factors. Remember that? So this is logistical growth. Okay. And so we're going to limit how much the grass can grow. And so let's watch what happens this time. Okay, so now as the sheep eat and reproduce, they eat more and more grass. All right, and then the wolves are growing up and down. Okay, I know this is going fast. I could slow it down, but it's not as fun to watch. All right, and so now the limiting factor on the population of the sheep is the grass growing. And so as you can see, now it's more of a balanced system because the sheep can only eat so much grass and only reproduce so many times, and the wolf population can only get so high, and neither species dies out. And so probably if we let this model run long enough, eventually one of the two species would die out completely. But as you can see, because of the limiting factor of the grass growing, neither species completely dies out. So that's pretty cool. So what this model shows is, I'm just going to go ahead and stop that here. What this model shows is how a population's growth is slowed and then or stopped by a limiting factor. And so there's a couple of things. It's either density dependent, so it's affected by the population of density, which means the more organisms there are, there's less resources, or it's density independent, which means it's not affected by population density. So these things, these limiting factors, would be like floods, fires, and landslides. So my question for you is the grass, when I made the grass a factor, is it density dependent or density independent? What do you guys think? Okay, if everybody's talking at the same time, I can't hear you, so let's do this. If it's density dependent, raise your hand. Okay, 1, 2, 3. I really can't see you guys. All right, how many people think it's density independent? Raise your hand. Okay, so the correct answer is density dependent. Yay, that's right, absolutely. Because as the more sheep there are, the less resources there is, and then eventually the sheep can't reproduce because there's no food to eat. And so some have to die. And then once they die, more grass grows, the population can go down. Exactly. Now, if we were to set a fire to the field, then that would be density independent. All right, awesome. Okay. I think this might be our last slide. It is. All right. So anyway, what we get to do next is you've got some work to do here. So let's get that loaded up. So go ahead and switch over to your workbook. I'm sorry. Let's turn pages in your workbook. You should have already been taking notes in your workbook. Hopefully you did. If not, you're going to have to watch this video when you get home. And we're going to go down to, go ahead and turn to page 15, I think it is. So go past all these notes that we get to take. All right. Our projects, go past all that, which I'll talk about the projects on Wednesday. And we get to right here, studying ecology practice. All right. So we got to match the term with its definition. So it's just matching. All right. So match up immigration to its definition. So we said the definition of immigration was what? Organisms going in or going out? Going in. That's right. So which one of these fits it? All right. Let's see here. All the living population. The arrival of individuals from outside an area. That sounds like it fits, right? That's individuals coming in. So yeah, so number 1 would be D. Absolutely. Okay. And then scroll down to the bottom. It says use each vocabulary term in a sentence. So we got 3 of these. Abiotic, age structure, and density dependent. So make sure you use these in a sentence that makes me understand that you know the definition. Okay? So abiotic, age structure, and density factor. Density dependent factor. So make sure you use those in a complete sentence. All right? And then we got to do this page right here, something about turkey vultures. All right, so you need to read this about turkey vultures, this graph. Then you have to interpret the graph and answer these questions, and then infer some information from the graph. So 6 questions right there. You don't have to go into great detail, just fill in the line there. And you can do this as long as the substitute or your teacher says it's okay. You can do this with a partner, okay? But this part up here you need to do on your own. Okay, so this you're doing on your own, and this real data thing you may do with a partner as long as you guys have been paying attention this whole time. All right, well, thank you guys very much for watching this episode of Mr. Richards Teaches Science. Remember, I'm Mr. Richards, and I'm teaching you science. If I've messed up in any way, please feel free to leave me a comment, and I can go back through and edit the video. Of course, I always want my stuff fixed. Other than that, you guys have a wonderful day. Adios.